Hello, and thank you for joining me today as we talk about work and how it relates to kinetic energy. So let's get started. So kinetic energy is the energy an object has due to its motion. So kinetic energy and motion go hand in hand. So if something's moving, it has kinetic energy. It depends on two things. First, it depends on speed, which is the motion part, and second, it depends on mass. Something that has mass has to be moving in order to have kinetic energy. The equation that puts all this together is kinetic energy is equal to 1/2 times the mass of an object times its velocity squared. So Ke equals 1/2 times mass times speed or velocity squared. And we're going to use this equation today. If you think back, we talked about work. And work is done, the net work is the work done by all the forces acting on an object. And this is equal to the change in the object's kinetic energy. This is known as the work kinetic energy theorem or the work energy theorem. So this indicates that the net work on a body equals its change in kinetic energy, which means that my work net equals my change in Ke or my delta Ke. And so that's going to spell out looking like this. Work net equals 1/2 mv squared final, v final squared minus 1/2 mv initial squared. And then you have to remember that work is equal to force times distance. So this all drawn out works like this. If you want to get real technical, we do cosine theta to make sure we're not at an angle, is equal to 1/2 mvf squared minus 1/2 mvi squared. And we can expand this out actually one more place. And we have this thing called a force. And force is equal to mass times acceleration. So we can actually simplify this even more. And we can break it clear down into mass times acceleration times cosine theta equals 1/2 times mass times velocity final squared minus 1/2 times mass times velocity initial squared. And now what you'll notice, with this theorem, we can divide everything by mass and we can take mass out of it. So I divide this side by mass, it comes out of here and out of here, and this side by mass, it takes this out. So I can actually cut mass out of everything. Not even worry about the mass of the object. And so we can get equal to A times cosine theta equals 1/2 times VF squared minus 1/2 VI squared. But we'll talk about this, we'll use this here in a second. So on a frozen pond, a person kicks a 10-kilogram sled, giving it an initial speed of 2.2 meters per second. How far does the sled move if the coefficient of kinetic friction between the sled and the ice is 0.10? All right, so here's our diagram. This is what's happening. Okay, so we know a couple things coming out. I know the mass is 10 kilograms, 10.0 kilograms. I know my VI is 2.2 meters per second. I know VF is going to be 0 because it comes to a rest. And I know my mu K is equal to 0.10. All right, so now we're using the work energy theorem. So I know that work net equals my change in Ke. Okay? And in this case, my force is going to be the force due to kinetic friction. So now I have to add one more piece. I need to know that my coefficient of kinetic friction, so mu K, is equal to my force due to friction divided by my normal force. And so now we can start talking. That I have a normal force, and I can solve this, so my force due to friction is equal to mu K times F of m, my normal force. All right, so here we go. Work is done by friction. So work is going to be my force due to friction, which is mu K times my normal force. And remember, my normal force equals mass times acceleration due to gravity. So here we go. My work is going to be equal to mu K, coefficient of kinetic friction, times my mass, times my acceleration due to gravity, times cosine of theta. In this case, it's horizontal, so it's going to be cosine of 180 degrees. Okay? Now, from here, this is going to be equal to my KE final. So remember, delta KE equals KE final minus KE initial. And this is 1/2 mvf squared minus 1/2 mvi squared. So that's what we're going to have here. We're going to have 1/2 m times vf squared minus 1/2 m times vi squared. So I am looking for how far this thing goes. So I need to get d by itself eventually. Oh, I didn't throw a d in there. Cosine, mass times gravity times distance times cosine theta. There's my d. So I need to get d by itself. What I can do now is I can divide everything across except for d. So I can divide all of this by mu k times m times acceleration due to gravity times cosine of 180. I can divide this whole side by this as well. So mu k times m times acceleration due to gravity times cosine of 180. So now what I'm going to do is I'm going to clear my screen for ink, and I'm going to, because I ran out of room, I'm going to rewrite everything. But I'm going to use that equation. So we have, I'll clear this side first. And I'll save that part. Okay, so now we have d equals. So on this, I'm looking at this, my m's cancel because they're everywhere. And I'm going to be left with vf is going to be 0, so I can cross off all of this. So I'm going to have negative vi squared, 1/2 vi squared on the top. I'm going to have mu k times acceleration due to gravity times cosine of 180. So d equals negative 1/2 vi squared over mu k times my acceleration due to gravity times cosine of 180. And so if I plug all this in, solve all this out, I'm going to have numbers. So I can put my numbers in my equation. So I have d equals negative 1/2 times 2.2 squared over mu k, we said was 0.1, times my acceleration due to gravity, which is 9.81 meters per second squared. This should have been meters per second. And then times cosine of 180 degrees. If you plug all this into your calculator, you should get distance equal to 2.5 meters. Plug that in, check my work, check your work, make sure we're on the same page. But that should be what we come out to. All right, and that is how we're going to do this. So now, let's run a different practice problem. Let's try something different. So in this one, Silvana Cruciata from Italy ran 18.084 kilometers in 1 hour, a world record time. If her kinetic energy was 694 joules, what is her mass? So now, I just have kinetic energy equal to 1/2 mv squared. Okay, and they didn't give me a v, so I need to remember that velocity equals distance divided by time. In this case, I have 18.084 kilometers divided by 1 hour. That's easy math. V is 18.084 kilometers per hour. Okay? What we need to do with this is we need to make this into meters per second. So you're going to convert kilometers per hour into meters per second. When I do that, I get 5.023 meters per second. And now I have a V. I have 694 joules. There's my KE. I'm solving for mass. So I know that I can get this, I can get mass by itself. Divide this side by 1/2 v squared. If I divide this side by 1/2 v squared, I can simplify all of this, make it look prettier. I can have m equals, I'm going to flip my 1/2, so 2 times Ke divided by V squared. So M equals 2 times 694 joules, all divided by 5.023 squared, and my mass comes out to 55.00 kilograms. I should have 4 significant digits because I have 5 here, and I have 4 there. I should have 3. So just 55.0. You can lose the second 0 on that one. 55.0 kilograms. Alright, there's your practice question. So now, give you a chance to try these on your own. So work through these, pause this video. I have the answers I'm going to show you on the next slide. So pause this right now and work through these 3 questions, and then your answers are going to be right here. So here's your answers. Make sure you check those. If you have questions, please let me know. Otherwise, thank you for your time and attention. And tomorrow we're going to talk about potential energy. So let me know if you have questions on this, and we will continue from there.